Hello, and welcome to today's webinar, How to Integrate Application Lifecycle Management, ALM, Tools with VectorCAST Test Automation. I am your host, Alicia McCullough. Our presenter today is Jeffrey Fortin, Product Manager, VectorCAST. We ask that you please remain muted throughout our presentation. We will have some polling questions after the slide presentation, and then we will have a demonstration, and then we will end the webinar with some Q&A questions afterwards. So if you have any questions throughout the presentation, please feel free to send them to me, and I will answer them at the end of the webinar. And with that said, I'm going to turn things over to Jeff. Jeff?
Thank you, Alicia. Always a pleasure to be here for these webinars, and thank you for joining us today. So as Alicia, we've got an agenda that starts with the presentations and some polling questions at the middle, and demo and quick Q&A. So we're going to start off, since we're talking about ALM and requirements, I thought it would be a good idea just to start off with why requirements are an important part of testing, and a little bit of background and thoughts and discussions about requirements and the relationship requirements have to testing. So many of our customers, if not most of our customers, are in a regulated industry. They are participating in some sort of a safety critical system development, and the systems that they build, the devices, the applications that they have some safety implications. And that's why it's very important that the software have a very high integrity level, and that it can be counted on to do the right thing. I've got up on this slide here the specification for the avionics industry, the DO-178C. And the reason why I've chosen this standard as opposed to any of the others, I think this standard states most clearly the requirement to have requirements-based testing. So if you read through the requirements for DO-178C, and if you happen to attend an earlier webinar that we had about our coupling capability, you know that the requirements that are in this standard state very clearly that the tests that you do must be requirements-based tests, and that you're not allowed to coverage for these to meet these requirements that are just tests for themselves. They have to be tied back and trade with some requirement. So this standard, DO-178C, calls out a couple of things. First, there is a requirement for requirement-based testing, both for low-level testing, or what we would call unit testing, as well as for integration testing. And that integration testing is important because it allows you to test those requirements with not just the stub code as you would in unit testing, but to test it with live libraries and making sure that the behavior of that software is consistent with the requirements. And then secondly, it has in the standard a requirements-based test coverage analysis. So that's what I was talking about before, where if you've got a coverage target that you must meet, and there are various coverage types that are spelled out in the standard depending on the type of criticality that you have or the safety impact that you have, that coverage analysis must be done with tests that are requirements-based. So you have to have some way to connect the requirements to the tests so that you are sure that these tests that you're running are part of the baseline requirements. So there are other standards that our customers use, such as 26262 for automotive, which also talks about requirements and testing. But I think the avionics standard is the most explicit in talking about those requirements, and it is an industry best practice. So there is a need for testing that is outside of requirements-based tests, but when you're talking about high integrity software and getting coverage for that software, you want to make sure that those test vectors are requirements-based tests. So a little bit about the software development process itself, and we normally use the V model to show the software process, but as I usually explained, this isn't solely for waterfall development. So if you're using some of the more modern software development techniques, such as Agile, Scrum, etc., then you're following this same process, but you're doing it in smaller batches, right? So you're coming up with user stories that are for a smaller part of the implementation. You're coming up with those requirements for a small part of the system, then going on to the implementation and the acceptance and validation of that small piece of the system, and then iterating that over time. So you're building that system piece by piece over time. Whereas with traditional waterfall, you tend to get all of the requirements up front and then implement those requirements. So whichever way you're doing it, traditional waterfall or the more modern agile approaches, still the software development process is the same. It's just the size of the cycle will be different. So as you go up on the testing side of the V model, you can see that we start off with software unit test. And for that, the product that's applicable for that is either VectorCAST C++ or VectorCAST Ada, depending on the language that you're using. C and C++ are both for the C++ product. And then as called out in the standard, if you're moving up to integration testing, where you're having not all of the units stubbed besides the unit under test, but you want to actually bring in the live libraries at the implement libraries, then we can do that within the C++ and Ada tool as well, and prove out the software integration testing. Now, I'm not going to show it in this webinar, but the same concepts are applicable if you're moving up system testing. And if you remember from one of our previous webinars, we talked about how you can have system validation or application validation testing done at the top level, as well as a type of integration test done there as well. So we sort of split that up into two different parts, the integration testing at the unit test level and then integration testing at the system or application level. And there, the product that you'd be using is our VectorCAST QA for that. Over on the right-hand side is VectorCAST Analytics, and Analytics is really a lifecycle tool. It fits in very well with the Application Lifecycle Management tools that we're talking about in this webinar, sense that it's collecting metrics throughout the entire software development process, and we're using those metrics to make decisions about release readiness, to make decisions about a quality analysis that we have on the software. What are we meeting our quality goals? Are we trending in the right direction? Are we following metrics that really inform us and help the decision-making process for wise use of our limited resources? So the VectorCAST Analytics product, and I'll be showing you some screenshots as well as live in the demo how the analytics product works with our VectorCAST tester test automation system. Okay, so that's a little bit about software development process and how the VectorCAST tools map into that process. So while we're talking about analytics, release readiness, one question I'd like to talk about now is when are we done testing? Now, a common answer to this question is a couple of ones, somewhat sarcastic, but a common answer is, well, when we hit our release date. And although I'm being a little bit sarcastic, it's actually true in a lot of cases where we set a date when we've maybe published to our customers when a particular release is going to be ready. And when we come up with that date, we say, well, we must be done and we're ready to release the software. Or maybe you have a QA department, SQA department that is making some decisions about when you're ready to release software, and when they say you're ready to release, that's when you release. So what we think is the correct answer to that question, when are we done testing, is really when the test demonstrates a high level of code coverage. And we talked about code coverage and what that means. But coupled with that is when we have tested all of the requirements. The requirements set the baseline for what we need to do for the system to work correctly. And the system engineers who developed those requirements had in mind all of the pieces that were needed for the expectations for that system. And once we've met all of those expectations, then we're ready to release the software. The code coverage goes along with that in the sense that our code coverage for those tests, we want to make sure that all of the tests have been, all of the requirements have been tested. Secondly, that the code that's being delivered in that system matches up with the requirements. So we want to make sure that we've got all of the requirements tested. And once we've tested all of that, we should see a very high degree of code coverage. If there is code that isn't covered, then you have to ask the question about why that code is there. Why is that code been into the system if it doesn't map back to any of the requirements that you have for this system? There might be a good reason for it to be there, but you really should be asking the question, why is that code there? And will happen if that code ever gets executed, since you've never tested that code and you don't know that you haven't set any expectations for that software. So when are we done testing? When the test demonstrates a high level of code coverage and that we have tested all of the requirements. The benefit for this is that the completeness is really easy to measure. When you're using VectorCAST test automation platform, the testing coverage comes as part of the testing itself. So if you're doing the work to come up with the tests, instrument the code, and allow the metrics to actually access how much of that code has been exercised as a result of running those tests. And the estimates of the remaining work are more accurate. So in other words, if you know that you need, let's say, to 100% statement coverage for you to meet your integrity level that you have system, and you're at 50%, well, you've got a clear estimate of what it takes to get to the rest of it, and you can use things like our analytics tool to figure out where does the remaining work have to be done, what are the red spots in the code where I should be putting more tests in and should be doing more detailed analysis of what that code is doing and how it maps back to the requirements and how I can improve the coverage for that particular module in the system. So when are we done testing? When the tests demonstrate a high level of coverage, when we have tested all of the requirements. And you really should be using VectorCAST, a test automation system that allows you to do this in an automated, mechanical, engineering disciplined fashion. Makes it a part of the software development process. Okay, that's about when we're done testing. So here's a screenshot of the analytics that I've just been talking about. So here's a sample dashboard that we have in analytics, and I've highlighted a few areas. I've highlighted an area on the left for the statement coverage. So our statement coverage in this case is at 22%. Traditionally, the requirement for most systems is to be much higher than that. We're closer to 100% is where we want to be. So right off the bat, just looking one metric on this dashboard, I already know that I'm way far away from being able to release this software. There's quite a bit of tests that are missing. There's quite a few things that haven't been checked out on this code, and I need to do some work to add more tests and tie those tests back to more requirements. As you can see, I've got the next thing I see at the top is the number of requirements that I have tested. So I've got over 3,000 requirements that have been tested. And of those 3,000 requirements, I'm still only getting 22% code coverage. So right off the bat, I would like to know what's the rest of that code that I've got in this system. If I've got 3,000 requirements tested and but only at 22%, what's the rest of the code doing? But if I look a little bit further, I can see highlighted down there is that only 5% of the requirements have tests that are passing. So that tells me a little bit about the code quality itself, not just the coverage metric, but telling me that I've got requirements-based tests and those tests aren't passing. So that's a pretty bad thing. I've got the test there, but the code implementation is not meeting it. So that tells me a little bit that I've got code problems, I've got implementation problems, I've got code coverage problems, lots of problems going on, and that's reflected in the heat map down at the bottom. You can see a lot of red areas have been put in that heat map. The red overall is a bad thing, but it's good in the sense that it's telling us where to focus our efforts with the limited resources that we have to improve the quality of the system. If I've got engineers that are working on the small green parts that you see down in the bottom right, maybe I can reallocate those resources towards the red areas so that we can get those red areas starting to improve and look better. And eventually what we need to do is we need to get this heat map as green as possible so that we can hit our release readiness targets and that we can improve the overall quality of the system. So this is just one page. This is just one dashboard that's in the analytics package, but the metrics that are being displayed here are giving us a wealth of information about where our project is, what's the state of the quality of our project, and what's the next steps that we need to do to improve that quality. All right, I'd like to spend a little bit of time now, since we're talking about requirements, to be a little bit philosophical here and talk about requirements ambiguity. So when we speak about requirements, requirements are written in a natural language, and they're subject to interpretation, right? We read the language of the requirement, and we need to understand what was meant by that requirement. So the very first thing we want is we want to make sure that when we're writing these requirements, that these requirements have some testability behind them. So we want to write requirements that are testable. When we write requirements that aren't testable, certain assumptions are made, interpretations are made, and those usually have bad consequences. So if we have a requirement that isn't testable, maybe what we need to do is we need to refine that requirement a little bit more and create some derived requirement from that higher level requirement that isn't testable. So that's one way to improve the situation is if you're given a requirement and that requirement itself is not testable, maybe we can create some derived requirements from it and that those derived requirements can be testable. One thing, Alicia is going to include this in the information for the webinar, but there's a blog post on our website that talks about software correctness and what does it mean for your software to be correct. And in that blog post, there's a link to a really good paper that's on the IBM website. And that is talking about some of the things that are needed to write good requirements. The paper, in fact, I've got it in front of me right now. There's a paper written by Ivy Hooks, sort of dated. It's way back in 2001 is when this paper was developed, written, or published, I should say. But it has some really good tips about writing good requirements. And some of the things that are in the paper is to make sure that when you write a good requirement, you make sure that there's a need for that particular attribute that the requirement is. If it's not needed, why are you putting the requirement in there to begin with? To make sure that it can be verified, or in other words, I put here, make sure that it's testable. Make sure that it's an attainable requirement. So if you write a requirement and there's just no way to do that, that's not a good requirement. You need to make sure that there's some way to accomplish the task that the requirement states out. And then lastly is to make sure that it's clear. Make sure that there's absolutely no ambiguity in the requirement itself. There's a common understanding of what that requirement means. So there's a good paper, and I'd suggest that you download that. It's available on the internet. Writing Good Requirements, paper by Ivy Hooks.
Jeff,
right,
if
so
you also, I'm sorry, I wanted to let everyone know that it's also in their console. If they look at their screen, below are some icons, and the blog post is located in there. So they can get it directly right there on their screen.
No, perfect. Good. So some examples that I've come across in my past lives of requirements that were given to me that weren't testable or were ambiguous were the fan blade shall stop soon after requested. Well, you can tell right away that that's got some issues with it. Soon is not very well defined. What does soon mean? What's the request that actually causes it to stop? What does stop actually mean? How do we measure what stop is? There's lots of things that are ambiguous. Now, one of the dangers of writing unambiguous requirements is you start to cross the line into the implementation. So we don't want to talk about implementation in the requirements itself. We want to talk about more about what is needed, not the how, but really being crystal clear about the what is what we want to do with requirements. The second one is a really good one. All messages shall be encrypted. Is it really all messages? What type of encryption is it that you need? Again, when you talk about the type of encryption, now you're talking more about the implementation. This requirement, all messages shall be encrypted, is more of a design goal rather than a requirement itself. And the requirement should really be talking about what's the objective that we want to get in the system. In this case, the objective is to have a secure system. So we want to make sure that the messages can't be read by folks that aren't the intended recipients for these messages. So it'd be better just to say that rather than talk about all messages shall be encrypted. So the impact is if you're not clear about these requirements, the implementer will decide for you. So to implement the system, things have to be implementable. So if you write the requirement and it's not made clearer, the implementer will make it clear. And those decisions that the implementer makes become implicit requirements in the system. They're never written down. They aren't tied back to any test case. They just become a part of the implementation. And when the system is finally delivered and you go through your validation efforts, you'll often that you'll miss validation acceptance because of these implicit requirements that were the implementers, because the requirements started off ambiguous. So this is a source for most of the bugs and validation errors that come in the system, that end up in the system, are these interpretations of what was meant by the requirement. So one way you can fix this and address this, besides following the advice that's in the paper about writing good requirements, is when the author requirement, typically a system engineer, writes the requirement, it's a good idea to have that system engineer write an acceptance test case for that requirement and have that done at about the same time. The reason for that is when you write the test case itself, it forces you to think about what the requirement is meaning. So when reading in a natural language, you have the tendency to want to drift or be ambiguous, but a test case by its very nature is not ambiguous. You're writing down the exact logic or acceptance, the way it's going to be accepted, and that causes you to think more about the requirement and what is meant. And if time between you write the requirement and you write the test case is short, it's fresh in your mind that you've got a clear understanding of what you meant when you wrote this down, and you're going to write a very clear acceptance test case at that time. It's sort of like TDD. We talked about TDD at the implementation level and using TDD to drive an efficient implementation process. In this case, we're driving an efficient system validation process where we're writing the requirements and the acceptance test cases right at the same time. That's bringing clarity into the system and makes it quite clear for the implementers to know what the goal is. The goal is to pass the acceptance test case. And I've got a clear requirement and I've got a clear acceptance test case to help drive that behavior. Okay, so that's enough on writing unambiguous requirements. So we'll move on to how VectorCAST helps with these requirements and bringing them into the testing environment and the test automation process. So within VectorCAST, we have something called the Requirements Gateway, and that Requirements Gateway is the portal, if you will, or the gateway that allows to bring requirements into the test automation system, into VectorCAST, and have those requirements be associated with the test cases that we have in the test environments. As you can see from the list, the screenshot that I on this slide, there are a number of subsystems that we support. At the top is a CSV or an Excel spreadsheet. And then there are a number of offerings out in the marketplace that we've done integrations with, and we know how these systems work and what types of information is needed to tie into those requirements repositories. And then at the bottom is just a custom slide. It allows you access to sort of a generic script that allows you to connect to some custom system that you might have that we don't have on this list quite yet. So for the next few examples, I'm going to be using the CSV as the subsystem that we'll use. Most people understand what an Excel spreadsheet is, and so we'll use that in the examples for the next few slides. So in the next is the importing requirements from the requirements gateway. So if you've got that CSV file and that CSV file has a mapping of the, has the listing of the IDs and the requirements and a description of the requirements, then we point to that CSV file. We map the fields that are in that CSV file with the fields that we have within VectorCAST, and we come up with a list of requirements from that CSV file, and we can display them and show them in the requirements gateway section of VectorCAST. So there you're seeing a screenshot of the requirements once they've been brought into VectorCAST and be able to view them and see that we've got all the requirements that were specified in the spreadsheet. Once we've those requirements and then we go into our test cases, we can now associate the requirements that we have with the test cases that we have. So we, in the information that's at the bottom for the test case, there's a place for us to put notes and some other information, but included in there is the requirements mapping. So what will be listed is all of the requirements that we've brought into the system, and then we can simply select the requirements that are applicable for this particular test case. Once we have that association made, we will see that the requirements have been associated with the test case, and then we can use our dashboard to be able to track the number of requirements that have been tested, and we can of course bring that information out or back to the requirements database system itself, or export them back to the requirements system that we're using. So that's the mapping between the requirements and the test cases. And this is the critical mapping that I talked about at the beginning to make sure that the tests that you have can be mapped back to the requirements that you have for the system. If you've got tests in here that don't map back, you'd really have to ask, what is the objective of that test if it isn't testing one of the requirements. There are cases where it's needed, but it allows you to make the decision what tests you have and whether those tests map back to a requirement. Okay, no problem. So you should be seeing VectorCAST right now, and coming up on the top left, you'll see the testing environment view. So here I've got tests that have been put for this system, and I've got a connection here. This requirements gateway over on this side. You can see, as I said, there's the CSV system that we talked about in the presentation, and a number of the others, as well as IBM CLM. We're going to use the IBM CLM ALM system for this particular one. So before I go into VectorCAST, let's take a look at system itself. So here I have a server running IBM CLM, and I've got a number of artifacts that have been requirements that have been set up for this restaurant example that we have. This is a restaurant manager example, and you can see I have folder A, folder B, and this folder BA. Not very informative, but that's what they were named. And within folder BA, I have a module. So if I click on the module, what that will do is show me the requirements that I've specified for this module so far. Okay, so I can see I've got requirements. The system will support 6 tables. Placing an order updates the table's occupied status true within the table database. All the way down the line, I can see there's requirements about orders. I can see there's requirements about how the order will be happening, et cetera, et cetera. So if I click on one of these requirements, 44 for instance, I can see over here the links. Now if I had any test cases, those links would show up here. So what we're what we need to do is we have the requirements, but we don't yet have any test case links to what is testing those requirements so far. So our next steps really is to go into VectorCAST. And when we go into VectorCAST, what we'll do is we'll connect to that ALM system, in this case IBM CLM. And the first thing we need to do is authenticate ourselves. So there's a number of parameters that come up that allow us to connect to, in this case we're using Doors Next Generation with IBM CLM. And we go ahead and authenticate ourselves. And once we do that, we can see that we had success and we're all connected. So now VectorCAST is connected with the ALM, all set. And the next thing we want to do, bring those requirements into the system. If you take a look, we don't have any requirements yet. And if we import them, what we'll do is we'll get a dialog box that allows us to find the requirements that we want to import for this particular system. Make this a little bit bigger. And if you remember that we were in folder BA, I'll just bring it up again so you can see it. So the folder that we want to bring in for is this folder BA. You can see that that matches right up with what we have here. So folder BA, we can select on that. We want module. Bring that over. We want module BA. So you can see this is all lining up. And what we want to do is we want to map the pieces that are in the module to the, so you can see the ID in the description here. We want to match those pieces up to the keys that we have within VectorCAST. So we have a key, title, and description, and that'll map to the identifier and the descriptions that we have in IBM CLM itself. So we go ahead and import those. And we can see that they all imported successfully. We can view them, and now we can see all those requirements coming up over here. So we've now taken all of the requirements that are in IBM CLM for the module module BA. We've brought them into VectorCAST, and now we can start using those requirements to associate them with test cases that we have in the system. So we'll go back to the test case here for this place order test case, and there's a couple of place order requirements here, 44 and 45. So place an order will update the occupied status, and placing the order will update the table number. So if we take a look at that test vector, we can see that we've got the is occupied will be set to true, and the number in party will go to 1. So that number in party will allow us to see the increment from the number in party incrementing, that was the requirement, and see that the is occupied status now goes to true. So down at the bottom, remember I showed you, here's where the requirements are in the system. We can take a look at all of the requirements. And what we want to do is we want to map this 44 and we want to map 45 to this particular test vector, because this test case is actually testing those two requirements. So when we make that association, we'll now have the information updated for the two requirements, and we can see that this particular requirement here has been updated with those two requirements. So we'll go ahead and save that. And we actually will see that if we hover over that place order test, we can see that there are two requirements that are associated with this test case. All right. And next thing I want to show you is the dashboard. So here I've got a dashboard that's associated with this, and you can see that there's nothing here yet. And the reason for that is because we haven't run a test case yet. So we don't have any coverage, we don't have any requirements that are on here yet. It's because we haven't run anything. So if we go ahead and run that, I'm just going to close that environment and run it through the project manager. It will give me a couple of information here. These are the two tests that we just added to that test case. Accept those. And now we can go ahead and execute those. All right, so now we've executed all the tests. We can see that we've got some statement coverage here. We're at 26% statement coverage. All of the test cases have been run and all of them have passed. So we should see that information now being updated in the dashboard. So we'll update this here. We can see, sure enough, we've got the coverage showing up. We've got 2 requirements that have been tested. All of the requirements, there's 2 requirements, all of them pass, or 100% passing. That's great. And if we click on that, we can see which one of the functions have requirements associated with them. So we can see that it's the place order that has those 2 requirements. Those are the requirements that we put on place order. So you can see there's a nice match between the dashboard, between the VectorCAST automation, test automation platform, and IBM CLM, which is where our requirements are. So to complete the loop, we now have these requirements. They've been tested. And what we really want to do now is we want to update that information in the ALM system and bring that back into Doors. So we'll go ahead and open up the requirements gateway. And now what we want to do is we want to export these requirements into the ALM system. There are a number of projects that have been defined in here, but the default is selected for us correctly. And we'll go ahead and export those. Okay, everything is good. Everything's been exported, so let's take a look at that now. So remember, it was 44 and 45 were the 2 requirements that we associated with a test case. So if we click on 44, we can now see that the link has been updated, and that link is now showing us that the place order function within the test environment module BA environment is the test case that will validate this particular requirement. And we did 45 as well, so we just take a look at 45, make sure that's been updated. Our links will update, and sure enough, they'll say place order test number 1 within the module BA environment in VectorCAST is the test that's validating this particular requirement. So that completes the loop. We have our requirements defined within IBM CLM. We bring those requirements into VectorCAST. We have test cases defined within VectorCAST. We associate those test cases with requirements. Once we run that, we see that information all being updated in the dashboard, and we can export that information back to IBM CLM and show the tests that actually validate the requirements themselves. So that's how you integrate your ALM system into the VectorCAST test automation platform and have a complete end-to-end system. Okay, so that's the end of the demo, and just in summary, the requirements really form the basis for developing correct software. And the blog post that we have there really goes into some more detail about that. But really, when you're specifying software, you really need to have some rudder of where that software is going and what direction and what course it's taking, and the requirements form that basis. So having requirements that are clear, implementable, necessary, needed, attainable, etc., that's really the basis for developing correct software. And then VectorCAST Test Automation Platform works with your ALM. I've shown you the list of ones that we've integrated in addition to sort of the generic spreadsheet implementation, a CSV file, and then a custom implementation that just allows you to connect to any system at all, whatever ALM system you have. And that finally, the testing metrics allow you to make fact-based decisions about release readiness. So how much coverage do we have? Where should our testing efforts be? How many requirements have I tested? Et cetera, et cetera. So that those metrics that are in the dashboard is really what's driving your decisions about how your limited resources should be used. Okay, so that's the summary, and we're now ready for some questions. Answers.
Okay, Jeff. The first question that we have is, what is the difference between software qualification test and system qualification test?
Mm-hmm. Yeah, so it's a bit of a generic question, and I hope I'm interpreting it correctly, but software qualification tests really are talking about the implementation of for itself, so the requirements are on the software, whereas system qualification tests tend to talk about behaviors of the system overall or attributes of the system, like how much it should weigh, the environmental considerations for the system, et cetera, are generally what we refer to as system acceptance criteria, and as opposed to software criteria where we're talking about the behavior of the software itself. So hopefully I interpreted the question correctly.
Okay. Next question is, I need to write scripts for PTC integrity integration. I need to write scripts. Does PTC integrity integrate with VectorCAST? Does that make sense?
Okay. It does make sense. So there are scripts that are there, maybe as a starting point, but they might need to be customized for your particular implementation. But our folks will be can help out with that. Besides, what's in the manuals themselves for the scripts. But yeah, really any ALM system or requirements repository can be integrated in with VectorCAST.
Okay. The next question, how do you analyze the impact of changing requirements, doors, baselines on VectorCAST C++ tests?
Say it one more time.
Okay. How to analyze impact of changing requirements, in parentheses, doors, baselines, on your VectorCAST tests?
Oh, okay. So the impact analysis of the requirements themselves and not the software code itself. Well, the impact analysis that we have within VectorCAST is taking into account source code changes. So let's make the assumption that when you change requirements that there's an associated implementation change for those requirements. That implementation change would result in source code changes, and we would know what parts of the system have to be revalidated based on those software changes. Now, as far as associating those new requirements with test vectors or adding test vectors, even from that perspective. So let's say, for instance, I'm making some assumptions, and I'm sorry I have to make so many assumptions, but let's say that you've run all of your test cases already. You add a requirement, and when you add that requirement, it causes you to add 2 more test cases to test that requirement. So you're in a particular test environment, you add 2 test cases, associate those 2 requirements. The impact analysis that we can do within VectorCAST will say, look, those 2 test cases haven't been run yet. You need to run those 2, and those are the only 2 that need to be run because those are the only 2 new ones that you have. Like I said, we'll also take into account any other source code changes that occur, and we'll rerun any test vectors that have to be rerun because of those as well. So it's kind of a multi-part answer to that question. I'm sorry, but what we're doing is we're taking a look at the source code base, and we're taking a look at what tests have not been run, and based on those 2 things, we'll make a decision about what should be made next. Of course, you can override that and simply run all of the tests if you wish to, but to save time, the impact analysis is done, and we come up with the minimum subset that's needed to get you to a complete answer.
Okay, great. Another question is, where is mapping between requirements and code changes associated with it? In the ALM tool or in VectorCAST?
Within VectorCAST.
Okay. The next question is, can VectorCAST get requirements from doors?
Yes. Yep, doors, the classic doors, as well as doors next generation, both.
Okay. Can VectorCAST also do coverage by analysis?
Yes, it can. I didn't show it here in this demonstration, but there is a coverage by analysis window that allows you to put your coverage justification in that editor, and then that code will show up as being covered.
Okay, and let's see. Does VectorCAST connect to HIL systems test automations like ProTech, ECU test, or similar?
VectorCAST is a software test automation platform, and these Hill systems, IL systems, are what Vector Group overall is involved with, and you've mentioned some others as well in that question. We did a webinar some time ago which showed an integration with some software that Vector makes called Canoe, and Canoe it integrates in with some of these Hill systems or HIL systems. So I'll say the answer is yes. But the part of the system that we're doing is the actual software testing and software coverage that's running within, let's say, an ECU, and the Hill would be the simulation system that's driving that ECU itself. So it works within that environment, yes, absolutely, but it's coming at it from a different perspective than, typically what you're doing is system level validation with a Hill system. So in other words, if I'm simulating a door being opened on a vehicle, then that Hill would simulate the signal of the door being opening, and I want to see that, if I open the door, then the alarm goes off that says the has been open. That's typically the level of testing that you're doing there. But if you actually wanted to see, what code is being executed when you run that particular test scenario, that's where VectorCAST would come in. So you'd have your code instrumented, you'd run through those higher level system tests, the door being opened and then the alarm going off, and then you'd be able to see and validate, did the code units that I expected to have run, what kind of coverage I get when that system level test was run. Like I said, we showed that using a simulator within Canoe, and we did a webinar on that several months ago. I think it was last November, if I remember right. So if you're interested in that, look up that webinar, because that sort of shows you towards the scenario that you're talking about.
Okay, and let's see. Does VectorCAST integrate with Jenkins?
Yes, it does. So if you're doing continuous testing and or continuous integration, and you want to have these tests being run as you check in your code or check out your code or do your the system can be plugged in directly with Jenkins, and we actually have plugins on the Jenkins site itself. So if you take a look in the plugins section on Jenkins, you'll see plugins for VectorCAST, and those are a great starting point for getting that integration up and going. There's a lot of parameters that Jenkins has, and it can be a little bit daunting about what has to be set. So that's why we develop the plugins to give you a start on that. Just fills in the necessary parameters that are needed to integrate in VectorCAST with Jenkins.
Okay, and we have time for a couple more questions. What is the impact of re-importing new requirements baselines? What happens to the previous requirements import?
Mm-hmm. All right, so what you're asking is I've imported requirements and I've made associations, and now I want to bring more requirements in to the system. So the basis of that is the ID itself. So we need to make sure that if the IDs collide, then there's not much we can do about it, but more than likely they do not collide if you're using the same system. So it's coming up with its own unique IDs that are provide the integrity of that database within the requirements system that you're using. So as long as you're bringing in new IDs, they're additive. It's fine. If you have a collision, then it will overwrite the previous one. So that shouldn't be a problem. But as long as the IDs are unique, you're in good shape.
Okay, great. And the last question is VectorCAST 2018 available now?
Yes, it is available now. If you take a look at our website, we're at Service 1. Yep, it's available for download and ready to go.
Okay, great. All right, that's all the time that we have. If you have any more questions, please feel free to keep them coming in and we can answer them offline. I would like to thank Jeff for your time today.
You're welcome.
And please, if you have any other questions or would like to learn more about VectorCAST, please feel free to visit our website, www.vectorcast.com or www.vector.com. Thank you very much and have a pleasant day.